Hi there, folks. This is the Unit 10 review, and as always, I am the amazing Mr. Jansen, so away we go. If we look at the first one, this whole factorial thing, if you see the 5 with the exclamation point, remember that's our factorial symbol, which means we just do 5 times 4 times 3 times 2 times 1, and we plug that into our calculators and we get 120. Okay. For the next one, when we have a fraction with these factorials, we can reduce these. Just imagine if I have 27 going all the way down to 1, and I have 23 going all the way down to 1, everything from 23 on down is going to cancel out, which means this thing's going to reduce, and I'm going to be left with a 27, a 26, a 25, and a 24, but nothing else because everything else canceled out. And then this is just a job for my calculator. And when I do that, it looks like it gives me 421,200. Okay? The next one, we start off the same way. We're going to reduce this thing a little bit. The 52 and the 50 cancel out and leave me with just a 52 times 51. Again, everything from 50 on down cancels. So I reduce with just a 50 factorial, but then that also leaves me with a 2 factorial in the denominator, which is just a 2. And now, once again, I could reduce this a little bit further. I could do the 52 and the 2 and reduce that to a 26 and a 1, or I can just plug this into my calculator the way it is. But the point is, I'm going to plug it into my calculator again. So I get the 1,326, and that's it. If I look at the next one, again, imagine 87 going all the way down to 0 and 86 going all the way down to 0. Everything from 86 on down is going to cancel out. The only thing I'll be left with in this example is the 87, so that's my answer. All right. Number 5, 0 factorial. This is one of our special cases. 0 factorial is always 1. All right. And it's like the arrangement of 0 objects. There's still one way I can do it by arranging nothing. Okay. For these, I'm going to be plugging these into my calculator just using the permutation or combination buttons that I have. So if I pull up my calculator here, the permutation button, I just do 5, choose permutation 2. And remember to type this in, you just hit the 5, and then you go to math. So we hit the math button that's right here. We go over to probability, which is the PRB, and then we find our permutation button. And so now we punch in the 2, so I hit the 2, so it's 5 permutation 2. I hit enter and it'll tell me that this thing is a 20. Alright, and granted you could use the formula that we have for these, which might reduce the time it takes to do these, but there it is for this one. You can just punch it right into the calculator, so that's a 20. Same thing with the next one. We go to the 7, so I hit the 7, then math, over to probability, down to the permutation button, and then the 3. So it's 7, choose 3, which is 210. For numbers 8 and 9, it's almost the exact same thing. I'm going to use the calculator again, but this time I need the combination button. So I start off the same way. I still hit the 6, and then I go to math, over to probability, down to the combination this time, and then I punch in the 2. Okay, so it's the combination of 6 to choose 2, which gives me a 15. And again, that's one that's easy enough that you could do in your head if you remember the formula. All right. And then the next one, in terms of the combinations here, we've got a 7 combination, so math over to probability, down to the combination button. Choose 3. That gives me a 35. Okay, so just using those buttons that are available on the calculator. If I look at the next one, there's 2 ways that I could approach this particular problem. I can either look at this and as soon as I see the word arranged, know that order matters for this one. I don't want to cross out the word, I want to underline it a little bit. There we go. So arranged means that order matters, so I could use a permutation for this one. And since there are 4 total books, it's the permutation of 4 choose. Well, I'm putting all 4 of them on the shelf, so it's the permutation of 4 choose 4. And I could plug that right into my calculator, and it'll spit out a 24 for me. Or you can think of this in terms of the fundamental counting principle. I've got 4 blank spaces I need to fill. There are 4 options for slot number 1. Well, now I've used one of those books, so now there's only 3 options left for the second slot, and then 2 options, and then 1 option. And I multiply, and that also gives me the 24. So whichever way you want to approach this is up to you, either permutation or using your fundamental counting principle. For this one, it says, how many ways can a team of 3 be chosen out of 18 people? Well, here order does not matter, and the giveaway there is the fact that we're talking about a team. It doesn't matter what order they're chosen in. What matters is who's on the team. So this is going to be a combination, and it's a combination of 18 choose 3 because there are 18 total people, and there are 3 to choose from, or there are 3 that we're choosing. And for this one, I'll use the calculator because this one's we could do this one in our heads, but this one's probably, whoops, hit the wrong button. This one's probably a little bit easier just to do using the calculator. Okay, so it looks like you get 816. All right. The next one, how many ways can we arrange? And there's that word arrange down here. So how many ways can these letters be arranged? So order matters, but the problem is that I have repeated values. Like if I switched these two R's, it wouldn't be a different arrangement. So this is a permutation with repetition, which remember is our n factorial over p factorial q factorial dot dot dot, keeps going forever, where n is the total number. There's 7 of these, so it's 7 factorial over. Now I need to represent my repeated values. I have 2 r's, so I put a 2 factorial for the r's, and I have 2 a's, so I put a 2 factorial for the a's, and I have 2 c's, so I put a 2 factorial for the c's. And now this becomes a job for my calculator. I could reduce this thing a little bit with the 7 factorial and one of the 2's, and that would leave me with a 7 times 6 times 5 times 4 times 3. All right, so that's my numerator. The denominator, I still have those two factorials, which is going to be 2 times 2, which is 4. So I'm going to divide this thing by a 4. Okay, and that gives me 630. All right, so just be careful as you plug those into your calculator. Probably easier to do the numerator and denominator individually if you can, and then divide them. All right. For the next one, it says a standard number cube is rolled. What's the probability of rolling a number less than 5? Well, less than 5 means we're not including 5. Well, standard number cubes has 6 numbers. Numbers that are less than 5 would be 1 through 4, so there are 4 options for numbers that are less than 5. Over a total of 6 options, because there's 6 numbers on the cube. And now I just reduce that fraction to 2/3. And that's it. For the next one, it says one card is drawn from a standard deck of cards. What's the probability of a spade? So it's just the number of spades over the total number of options. Well, in terms of spades, there are 13 spades over a total of 52 cards. So that's just going to be a 1/4. All right. The next one says standard number cube is rolled. What are the odds of rolling a 5? So again, probability of rolling a 5. So the probability, let's think about that for a second. The probability would be 1 out of 6, okay, because there's 1 5 out of 6 total. But odds, remember, instead of favorable over total, it's favorable versus unfavorable. So there's one favorable option. It's one way of getting a 5, but there are 5 other ways of not getting a 5, so 5 unfavorable options. So it's 1 to 5, okay? Again, probability is what we want over the total. This is what we want versus what we don't want. So 1 to 5 for the odds, all right? Along those same lines here, I'm given the probability. I want to state the odds. Well, so the favorable is 3. The total is 7, which means there are 4 unfavorable outcomes. So it's 3 to 4. Okay? Instead of what we want over the total, it's what we want versus what we don't want. Going the other way, here's what we want versus what we don't want. So there's 3 ways I can get what I want. There's 5 ways that I can get something else, which means there's a total of 8 options here. 3 favorable and 5 unfavorable. So it's 3 out of 8 for the probability. Okay? In this one it says 2 marbles are pulled 1 at a time, and that 1 at a time is really important because that's what's telling us that this is going to be simple probabilities, all right? Which means I'm just going to set up my fractions, and I'll multiply if it's and, I'll add if it's or, all right? So it says to find the probability of green, then pink with replacement. So the probability of green, there are 9 green marbles out of 25 total marbles. The word then implies the word and, so I'm going to multiply. With replacement means I pull that green one out and I put it back. Now I pull a pink marble. There's 11 pink marbles out of a total of 25 still because I put the first marble back. And now we just multiply these. That's going to give me a 99 over a 625. And I don't believe that reduces. Okay? If I look at the next one, again, this 1 at a time, there's a key right here. 1 at a time means simple probability, so I'm just going to set up the fractions. So the probability of 2 pinks, and really what that means is I want to get a pink for the first marble, and then I'm going to pull another marble, so I want a pink and then another pink. So the word and is implied here, and so we start off with the pink, so a pink marble, that's 11 out of 25. But this time it's without replacement, so without replacement means that I pretend for a moment that I've actually pulled that pink marble out, which means there are only 10 pink marbles left in my bag, and there are only 24 marbles total left in my bag. All right. Again, we already established that there's an and that's implied here. It's a pink and a pink, not a pink or a pink. So it's a pink and a pink. So I'm going to multiply. And remember, when you're multiplying these, always reduce first. So like here, I can reduce the 10 and the 24 to a 5 and a 12. And then I can reduce a little bit further. I can cross-reduce the 5 and the 25 to a 5 and a 1. And now when I multiply straight across, that gives me an 11 over a 60. And keep in mind, this is something that you'll be expected to do on the non-calculator portion of the test, so you should be able to reduce these fractions and then multiply. All right, that's the way you should approach these problems. All right, for the next one, it says if you pull one marble, so again, only one marble is being pulled, which means I'm automatically only pulling one at a time, which means this is simple probabilities. So one yellow or one green. So one yellow, the probability of a yellow is 5 out of 25. Or means I add the probability of one green, that's a 9 out of 25. And these are mutually exclusive because there's no marbles that are yellow and green at the same time. There's no overlap. So I just have to add these together. And when I add them up, it gives me 14 out of 25. And that's it. Okay? If I look at the next one, it says there are 4 butterscotch and 12 chocolate cups of pudding. If 4 are selected at random, what is the probability of getting at least 3 butterscotch puddings? So this is one where instead of telling you exactly what we need, you have to come up with exactly what we need. So at least 4 pudding cups with at least 3 being butterscotch. That means I could get 3 butterscotch and 1 chocolate, or I could have 4 butterscotch and no chocolates, all right? And so now as I read that statement, 3 butterscotch and 1 chocolate, or 4 butterscotch, each of these things is going to become a combination, and that word and the word or will be replaced by multiplication and addition respectively. So for 3 butterscotch puddings, that's the combination of 4 choose 3, because there's 4 of them and I want 3, and 1 chocolate, so and means I multiply. Chocolate, that's going to be 12 choose 1. Or means I add. Combination for the butterscotch, that's the combination of 4 choose 4. And now it's just a job for my calculator. So this one, that gives me a 4. This gives me a 12. And this one gives me a 1. All right. So now I multiply. That gives me a 49 over here. I multiply and I add. So there's 49 ways that I can get at least 3 butterscotch. But now I also need to do something about the total, because I want the probability, so I have to put this over the total. Well, that's the combination of, I have a total of 16 pudding cups, and I'm choosing a total of 4 of them. And this one I'm going to do on the calculator, as opposed to trying to do it by hand here. And my calculator is being a little slow. There it is. So if I plug this one into the calculator, it's 16 combination 4. So 16 choose 4 gives me 1820. And so there's 49 ways I can get what I want. There's 1,820 ways possible of getting any 4 pudding cups. So now I have to do the 49 over the 1820. All right. And the last thing I try to do here is see if this thing reduces. I'm assuming that each of these is going to be divisible by 7, but we'll double check. And remember, on the calculator, there's a couple ways to do this. If you want the calculator to try to reduce it for you, you can do the 49 divided by the 1820. And then you hit math and tell it to convert that to a fraction. And it gives me a 7 over 260. If we were doing this by hand, you should be able to see then, and I already said it, that each of these is divisible by 7. The numerator divided by 7 is 7. The denominator divided by 7 is the 260. Okay? If I take a look at the next one, it says there are 1,300 students at Mr. Jansen's School of Hard Knocks. 750 are taking math, 350 students are taking English, and 250 are taking both. If one student is selected at random, what's the probability they're taking math or English? So it's just the probability of math, which is the 750 over the 1,300. Or means we add. English is 350 out of the 1,300. But then these are inclusive, so I have to subtract the overlap, which is the 250 over the 1,300. All right? So what I actually end up getting is the 850 over the 1,300, and now I just need to reduce that, which gives me 17 over 26. All right?